Open your book to page 916. In the previous lesson, we learned about how to find the limits using the table. For this lesson, we're going to learn how to find limits using algebra. So there are some laws. So like the first one, the first law, it says that when you have a sum of the function, you can go and find the limit of function individually, and then you add. So in other words, you can add, then take the limit, or you can take the limit, then add. The same thing with subtraction. You can subtract, then take the limit, or you can take the limit and then subtract. And same thing with the multiplication over here, that you can multiply, then take the limit, or you can take the limit, then multiply. So you can go either way. Same thing with division. You can divide, then take the limit of that, or you can take the limit of each one, then divide. And then over here on page 917, you have the power law. So same thing, you have the exponents. So you can do the exponents first, then take the limit, or you can take the limit first, then apply the exponent. So same thing with the root. So you can take the roots first, then take the limit, or you can take the limit, then take the root. Okay. So let's go over examples how this works. Okay. So let's go to example 1. On page 917, example 1, and let's do A. So you have the limit of x approaches to -2 of f of x plus 5 times g of x. Okay, so you have this part over here. So what you do is you go to the graph over here. So if you look at the f of x is a red one. So as it approaches to -2, the y approaches to 1. So this is going to equal to 1 plus 5 times. Now g of x is the blue one. So as x approaches to -2, the y approaches to -1. So this is going to equal to 1 minus 5. So this is equal to -4. Okay. Now let's go to B. You're looking for the limit of f of x times g of x as x approach to 2. Okay, so over here, again, if you look at the red graph, as x approaches to 2, as x approaches to 2, approaches to 1. The limit is 1. So as x approaches to 1, the y approaches to 2. Okay, so this will give you the 2. And the g of x, if you look at the approaches to 1, this one is going to approach to -1, this approach to -2. So this one does not exist. Okay. Now because this one does not exist, so the limit of this does not exist. So cannot. Okay, now let's go to C. Limit of f of x, you have a g of x as x approach to 2. So you can look at the red graph. Okay, so f of x is about 1.5, and g of x approach to 2 is 0. Okay, so again, this is undefined. Therefore, it does not exist. Okay. Now let's do D. So for part D, you have the limit of f of x to the 3 power as x approaches to 1. Okay. So again, if you look at the red graph as approach to 1, this is equal to 2. So this is equal to 2 to the 3 power. So this is equal to 8 for the D. Okay. Okay, now let's go to example 2. Now there are other methods of finding the limits. So let's go to page 918. Example 2. A. So you have limit of 2x squared minus 3x plus 4 as x approaches to 5. So whenever you're looking for limits, okay, the first thing you want to try is by direct substitution. Okay. So if you can substitute, then that would be it. So let's try this. So you got 2 times 5 squared minus 3 times 5 plus 4. And so this is equal to 50 minus 15 plus 4. And so this would be 39. And that's it. So if you can substitute, then go and do that. And do the same thing with B. Okay, you have the limit of x cubed plus 2x squared minus 1 over 5 minus 3x as x approaches to negative 2. So substitute. You can do one step at a time. So substitute, then you work it out. Negative 8. This one is 4, so plus 8. And then this is 5 when you multiply plus 6, right? So this is equal to negative 1 over 11. So again, if you can substitute directly, then do the direct substitution. So let's go to example 3. A, you have the limit of 2x cubed minus 10x minus 8 as x approach to 3. So you can first you try see if you can substitute directly. So this is equal to 2 times 3 to the 3 minus 10 times 3 minus 8. So this is 54 minus 30 minus 8. So 24, 32. Okay. So again, if you can substitute, go ahead and substitute. And then that's it. So you don't have to make the table all the time. You want to use the table as a last resort. Okay. So let's go to B. You got x squared plus 5x over x to the 4 plus 2 as x approaches to negative 1. So you can try see if you can substitute directly. So you got negative 1 squared plus 5 times negative 1. Again, whenever you substitute, put in the parentheses, it helps you keep track of the negatives. So this will equal to 1 minus 5 over 1 plus 2 equal to negative 4 over 3. And that's it. Okay. Okay, now let's go to example 4. So page 920. Example 4. You have the limit of x minus 1, x squared minus 1, and you got x approaches to 1. So this one, if you substitute 1 in here, you're going to get 1 minus 1, you get 0, so it's undefined. So this one you cannot substitute directly. So if you cannot substitute directly, then what you want to do is you want to do some factoring and do some cancellation. So you can make sure you have equal and you follow through. And this one you can factor into x plus 1, x minus 1. So this cancels out. So this becomes, again, make sure you show all your steps. Okay. Now you can substitute. So when you substitute, you get 1 over 1 plus 1. So equal to 1 over 2. Okay. So again, if you cannot substitute directly, then you want to do some factoring to do some cancellation. Let's go to example 5. You have the limit of 3 plus h squared minus 9 over h as h equal to 0. So again, you cannot substitute directly. If you substitute 0 in here, you're going to get denominator equal to 0, then you're going to be undefined. So again, in this case, you have to try to simplify. So again, there are many different techniques. Like this one, you have to do factoring to cancel. This one, you need to go and multiply out the square. So multiply, you get 9 plus 6h plus h squared minus 9 over h. And notice this will cancel out. And this one, so this cancel out. So this one you can factor out the h. So you factor out the h, you get 6 plus h over h. Now this can cancel out. So this becomes the limit of 6 plus h as h approaches to 0. So now you can go and substitute. So this will equal to 6 plus 0. Right? I can substitute. Now again, show steps. Yeah, because remember, math is communication, right? Not just getting the answer. So you want to show people how you get to the answer. Okay, so you can make sure you show your steps. Okay, so again, here's another technique. By multiply out, so you can simplify. Okay, now let's go to example 6. You have the limit of square root of t squared plus 9 minus 3 over t squared as t approaches to 0. Okay, so when you try to substitute directly, again, you're going to end up with 0 in the denominator. Okay, so whenever you have the square root, one of the techniques is multiply by conjugate to get rid of the square root. So what you want to do is you want to multiply by the conjugates. So again, there are many techniques, right? So make sure you know all the techniques. So multiply by the conjugate. Okay. Now make sure you keep the limit until you're ready to evaluate. So when you multiply, now do not multiply the bottom. Okay, you leave the bottom alone. So you're going to get t squared, square root of t squared plus 9 plus 3. Again, do not multiply the denominator, or else you're going to get stuck. Okay, leave the bottom alone. So over here, when you multiply conjugate, right? You just multiply corresponding part. So this you're going to get t squared plus 9. Minus times plus give you minus. 3 times 3 give you 9. Okay, and so from here, so this and this cancel out, right? So this cancel out, and t squared cancel out. So you end up with 1 over square root of t squared plus 9 plus 3. So now you can evaluate. Now you can put a 0 in there. So this is equal to 1 over, again, make sure you show your steps, right? So when you put in parentheses, when you substitute. So this is equal to 1 over, so this is going to give you square root of 9, will give you 3. So this is equal to 1 over 6.